Hello everyone, this is Mark Anjoluyun and I'm going to show you how to solve Newton-Raphson Method and Trapezoidal Rule using C++. Let's start with Newton-Raphson Method. But first, let me give you a brief background about this method. It is a root-finding algorithm which produces successively better approximations to the roots or zeros of a real-valued function f of x equals 0. It uses the idea that a continuous and differentiable function can be approximated by a straight line tangent to it. It was named after Isaac Newton and Joseph Raphson. The idea is to start with an initial guess which is reasonably close to the true root, then to approximate the function by its tangent line using calculus, and finally to compute the x-intercept of this tangent line by elementary algebra. This x-intercept will be a better approximation to the original function's root than the first guess, and the method can be iterated. Given the function of unknown roots, the method is solved using the formula x sub n plus 1 is equal to x sub n minus f of x sub n over f prime of x sub n, where x sub n starts at x sub 0, which is the guessed initial value. The value of x sub n plus 1 is a better approximation of the root than the preceding one. The process is then repeated until a sufficiently precise value is reached. The process can be stopped if any of the following conditions is met. The computed f of x sub n is already 0. This means that you have the exact value for the unknown. The value of x sub n plus 1 is the same as the value of x sub n, or if the maximum number of iterations stated in the problem is reached. This is the program I used in Dev C++ to solve for the zeros of functions using Newton-Raphson method. As you can see here, the limit is 1 times 10 raised to negative 9 to give a more precise value of the final answer. This is the program. And this is the actual program in Dev C++. And the scope and delimitation of the program. The program can only solve polynomial functions with maximum degree of 6. The program cannot solve if the values obtained in the iterations using the guessed initial value are not converging. The program cannot solve non-real zeros, and the precision of the final answer is 0.000000001. Let's start with these sample problems. Find the zeros of the following functions using Newton-Raphson method given their initial values. Let's solve first for f of x equals x raised to 6 minus 2x raised to 5 minus 3x raised to 4 minus 4x cubed plus 5x squared minus 6x minus 240, where the initial value of x is 0. This is the actual execution of the program. Let's execute the program. The initial value is 0 and the coefficients are 1, negative 2, 3, negative 4, 5, negative 6, negative 240. And the program will display the answer, which is negative 2. The answer is negative 2. And let's check this using a scientific calculator. X raised to 6 minus 2, x raised to 5 plus 3x raised to 4 minus 4x cubed plus 5x squared minus 6x minus 240 equals 0. Shift solve, and and that's the answer, negative 2. And let's solve the other one. F of x equals 12x raised to 5 plus 10x cubed minus 15x squared minus 30, and x sub 0 equals 1. Let's execute the program. The initial value is 1. The coefficients 0, 12, 0, 10, negative 15, 0, negative 30. And the answer is 1.23206. Let's check that using scientific calculator. X raised to 5 plus 10x cubed minus 15x squared minus 30 equals 0. Shift solve, and the answer is 1.232058178, which is the same in the final answer in the program. And let's have trapezoidal rule. Let's start with an overview. In numerical analysis, the trapezoidal rule is a technique for approximating the area underneath a curve. It works by dividing the area under a curve into trapeziums and calculating their areas. The more sets of trapezium are cut under the curve, the more accurate the computed area will be. The integral is approximated by partitioning the integration interval, applying the trapezoidal rule to each interval using the formula area of the trapezoid equals height times the average of the two parallel sides, and summing the results. The figure shows the area subdivided into sets of trapezoids. And this is the program in Dev C++. This program can only solve cosine 3x plus e raised to 2x, as seen in the first scope and delimitation of the program. And the executable file cannot solve any functions other than f of x equals cosine 3x plus e raised to 2x. However, the existing function can be edited in the program to solve other functions. The program cannot solve discontinuous functions. Let's try these sample problems. Find the definite integral of the following functions using trapezoidal rule given their lower limits, upper limits, and the number of segments to be used. Let's start with f of x equals cosine 3x plus e raised to 2x with lower limit 1, upper limit 2, and number of segments 12. Let's run the program. The lower limit is 1, upper limit is 2, number of segments 12. And there you see it, the total is 23.5197. And let's check this using scientific calculator. The integral of cosine 3x plus e raised to 2x from 1 to 2 equals 23.46437, which is approximately equal to the value in the program. And let's try the next one. F of x equals cosine 3x plus e raised to 2x from limits negative 10 to 10 with 1000 number of segments. Let's run the program. negative 10, upper limit is 10, and number of segments is 1000. And there, the final answer is 242,614,940. And checking using scientific calculator, the integral of 3x plus e raised to 2x from negative 10 to 10 and there you go, they have almost the same answer. These are my references in doing these slides. That's all. Thank you for watching.